Hello and welcome to October. This is our third math fix of the year. The support and enthusiasm about these tasks has been wonderful, and we're very excited to be sharing with you our latest math fix.
Today's math fix centers around 7.g.6. Solve real-world and mathematical problems involving area, volume, and surface area of 2- and 3-dimensional objects composed of triangles, quadrilaterals, polygons, cubes, and right prisms. This math fix is all about seeing if students can reason through a relationship between two similar 3D shapes and their surface areas. In this task, students have two similar 3D shapes, which are the same base and height, but one is a full prism while the other is a pyramid. They have to decide on the relationship between the surface areas. So this is a really great and fun problem that allows kids to explore the concept of surface area and use their modeling skills to help them along. If vocabulary is an issue, then images of a prism and a pyramid can help get over that hump. Formulas aren't much help here as they are with volume, so kids will need to think about what surface area is and how they can relate the nets of the two shapes to one another. Initially, kids might get some ideas about the relationship simply based on the number of sides of each shape. Prisms have 6, while pyramids have only 5 sides. If they are on this path, then they are doing well. Looking at the nets, they then might have some preliminary ideas about their relationships, but the key to this problem is also the proof they offer for their ideas. Here we can see that it appears to be a lot more surface area for the prism versus the pyramid. And if we thought about those shapes themselves and the relationship between the individual shapes, things get a lot clearer. Triangles are half of their related rectangles, and here we have very similar triangles sides to the rectangle sides. This means that each triangle is approximately half the rectangles of the prism. So, 4 triangle sides are about half of the 4 rectangle sides, and the pyramid has one less base, so the overall effect is the surface area of the pyramid is less than 1/2 the surface area of the prism. That said, as a very big bonus, there is a bit more to this story though. Our problem defines the pyramid as the same height as the prism, but the triangle sides are actually slightly taller due to the slant. It's called the slant height. Think of the Pythagorean theorem. So if the slant height difference versus the linear height of the shape were to be maximized and the missing base minimized, we might be able to get the pyramid's surface area to be equal to or even larger than half of the prisms. Never totally equal, but maybe equal to or larger half the prisms. This is a limits type of problem they will encounter later on in calculus, but for now, the original line of thinking is still a great starting point.
Well, that's it. That's our latest math fix. Excited to see how you and your students engage with that, so give us a comment or a like and let us know how things are going, and we'll see you again next month.